Hello. Thanks, and sorry about that. I actually
You're good.
see room 3 earlier, thinking I would be there first, and then it turns out that the same name is used in different places on Midspace. So I was listening to program comprehension questions and answers, and luckily my co-author alerted me that.
Perfect. Well, you came just on time. Perfect. So,
I apologize.
welcome everyone to this session on teaching software engineering skills 2. So I'm very happy that you all decided to join this session, which I think is a very important session, right? Because teaching is extremely good and valuable. And you will now hear the train going by because the CMU campus is right next to a train track. So don't worry about the train noises. Um, we have 3 sessions or 3 presentations in this session. I'm very happy to welcome Jeff, Andre, and Marcelo, who will present their respective papers. We're also joined by Valeria, who is our student volunteer. So if you have any questions or need help, then reach out. For the questions, we tried the raise hand feature, but that doesn't seem to do much. So either please just write your question into the chat or switch on your camera and raise your hand physically, or also just feel free to sort of contribute with your voice if you're comfortable with that. When you ask a question, we're always happy to see your faces. So if you switch on your camera, that's always greatly appreciated. Otherwise, yeah, very happy to stay anonymous. So with those slides, I'm very happy to welcome you all to this session. Going by the order that's listed here in the program, I'd love to start out with Jeff's presentation, Designing Divergent Thinking, Creative Problem Solving Exams. Jeff, are you able to share your screen? Or would you like to try that? All right, unfortunately, you're muted again.
Let me try. So this is
let's do this.
The plan.
So,
that's correct. Okay, where I'm looking for. Oh. Okay, so
that is looking good. Perfect.
Is that visible?
So in terms of, yes, we see it. That looks great. So in terms of organization, we have only 3 presentations in the session. So I don't think we need to stick to the limit per se, but if you're able to keep it around 5 minutes, that would be greatly appreciated. Afterwards, we'll have a discussion with everyone, and I think that would be the more interesting or the interactive part of the discussion. So if you're all able to stick around for that, we would highly appreciate it. Having said that, Jeff, take it away.
Okay, well, thank you, Christoph, for the great introduction, and sorry for adding to the stress coming in at the last minute. I was, like I said, I went to another session that had the same room name, and I was using too much of the model of the old system where we have actually physical rooms. So I'm speaking on behalf of my co-author, Casina Barral, and I did plan for a 5-minute presentation. So if maybe I'll let a few more words leak out, but I'll probably stick to at least very close to 5. So this is really, this papers, I call them experience report because it's from something we tried that was, occurred because of the pandemic and the sudden switch to online teaching. And it really is, it was motivated because I was trying to figure out, like a lot of us, how is it possible to run a final exam, preserve integrity, and assess the students when we can't actually watch them write on the paper, which is the traditional mode of giving final exams that I was thinking of. So at the time, spring 2020, I was teaching 2 different courses, and in the paper I talk about both of those. I'm going to abbreviate in this short presentation, but they're different. They're senior level courses, one in how to test software, so how to design and build tests and run tests automatically, a lot of test automation in there, and another course on how to develop web applications. So very sort of practical, hands-on, but with that different sort of way of designing and developing and deploying software. So what I decided to do is, from the final exam perspective, what I care about mostly is, can they do the things I want them to learn how to do? So skills demonstration, can they test software? Can they build a web app? So I decided to give them a task that they would do individually. Everything else in the class, by the way, was collaborative, and that's what I usually teach. And I borrowed, I took some inspiration from something called Odyssey of the Mind. So I'm not going to talk too much about that, but if you look that up, you might find it interesting, especially if you have small children, where they give problems that are uh, that emphasize creative problem solving and divergent thinking. And creative problem solving, of course, is one of the basic things we want to teach students, especially in software engineering courses. But the divergent thinking was my approach to let's to try to preserve integrity. That is, ensure that every student does something different. So divergent thinking means you have a problem that has multiple solutions, and different people will go in different directions, and but many directions are actually correct, or at least good solutions. Classic kind of software design in some sense. So this was my question: can I have enough divergence? And also I had other questions. So how long is it going to take to grade exams when everybody does something different? And that was actually a very serious concern. So we're all in spring 2020 with 120-hour weeks, and I decided that's a risk. If it's going to take me an unbearably amount of time to grade the exams, I'll just swallow that, and I'll do that. I'll cancel my vacation after the end of the semester. Uh, and how long would it take to create the exam? Because it was a different kind of exam that I hadn't created before, and the process I usually use would not work. So to cut a long story short, there are a lot of details in the paper, which I think is much more interesting than this talk. Um, is that we found it worked really well. So here are a couple of notes from the web development course. So it's fourth year seniors in the American system, how to develop web apps, and we talked about the concepts. But there's also a substantial usability portion in the course that was downplayed in the paper, partly to preserve and in a double blinding of the paper, because if I describe this course in detail, it would probably be it would be easy to narrow it down to at least 2 or 3 courses in the country. So I downplayed the usability part. It's more important in the course. So the divergent properties, which are things where students can make different decisions, belong in this list. So I gave them a collection of functional requirements, and this is done in Odyssey of the Mind. It's also done in product families, if you've ever seen that design technique from, well, 20 years ago, where I gave them n functional requirements, and each person chose a subset of those. So I think it was 4 to 8, 4 out of 8 the first semester, 2 out of 5 another semester. So in that range, they designed the software, which was the intent was to make it small because this is a final exam, and typically about 2 to 4 modules, but it depends, of course, on their design. They design the user interface, which adds a lot of divergence because there are a lot of ways to design even simple user interfaces, a lot of choices to be made, and many of which actually don't really matter in the sense of how good the user interface is, and the choice of technologies. And we talked about a few, but they also were free to choose technologies that we didn't learn in the course. So all of these things led to tens of thousands of possible good solutions. And indeed, every single exam was very different and easy to see that they're different. Surprisingly, it took me less time to grade because I was really grading one thing, and I didn't have to try to read handwriting either. So that was both of those saved time, and that was a big surprise to me. I think the loss is the deep theory was harder to assess with the kind of a skills-based exam, but it worked well enough. So I think it's a better exam than what I used to do, and that's what I'm doing now when we're teaching in person, and in the future especially for these courses. So thank you for your time.
So much. So I see a few virtual claps. I'll give you a physical clap.
Thank you.
Thanks very much for the presentation. Thanks for keeping it short and sweet so we have more time for some following discussions. All right, okay. Would Andrzej, would you like to try sharing your screen and telling us about reading to write code and an experience report of a reverse engineering and modeling course?
Let's see. Can you all see the screen?
This looks great.
This looks right. Good, good, good. Okay. Well, thank you, Jeff, for an awesome talk. I really like the approach, and just like you, this paper is about an experience where we wanted to focus on reading code, and this is joint work with Brooke Ryan, Adriana Mesa Soria, who's here, Kai Drafe, and myself. The inspiration for the course really lied in a lot of conversations I had with alumni. And here's one of our alumni who said, one thing that was counterintuitive is that in my first real software engineering jobs, I spent 80 to 90% of my coding time reading and 10% writing. This is, Eric Dashvi. He's not the only one who said this. Actually, lots of our alumni say this. And so when we had the opportunity to create a new degree program that I'll talk about in a little bit, I sort of said, sure, we should have a course like that. And surely somewhere else, such a course exists, and I can borrow some material and I can do this. And so I started looking, and what I found was that just about every single software engineering degree program, including our own that we had at the undergraduate level, focuses a lot on creating things, not necessarily having courses about reading code. So I ended up actually being stuck in the sense that I had to create this course from the ground up. And that turned out to be both a lot of work, but on the other hand, a really fun opportunity to do something completely different. So the course is reverse engineering and modeling, although I typically call it reading code. The name is just an old leftover of bureaucratic university processes because it takes forever to get a degree program actually approved. And the course sits in a 4-quarter professional master level program where about half the students are actually career switchers, people who have a different degree program, have dabbled some in programming, want to enter the computing industry, and have found this program. And the others are a lot of folks who've got a computer science undergraduate degree from somewhere and want to add to their knowledge by focusing on software engineering. So the focus of the whole course is really to learn how to read the code of an existing large-scale system to become an effective contributing member of its community, i.e. to learn, as especially these career switchers, to not be afraid of something that's 100,000 lines of code or greater, and to learn that you can become a member of the community and actually submit some pull requests, for instance. So essentially, we're mimicking the onboarding experience of you as a new engineer in a company. So the week-by-week lecture topics are layered. Week 1 is just course goals and logistics and expectations and some basic setting. Week 2 is where we talk about basic comprehension strategies, information foraging, hypothesis-driven versus inference-driven exploration of code base. Week 2, and that's just all very informal, just nothing, no detailed strategies yet, just here's high-level ways of conceptualizing what reading code is about. We layer mental models and mental simulations, so what happens mentally and how do you see the program. We then move into understanding that actually externalizing that into some formal notations can help you. We then switch drastically from being in the weeds to, but wait, you're doing this in an ecosystem of developers and expectations and ways that you're supposed to document things and submit test cases. That's the social context. There is a midterm, though I'll say something about that at the end. Then we bring in design patterns, test cases as a source for reading code. And then we switch a little bit to, okay, now that you understand how to read code, can you also actually design, for instance, a new feature and contribute? So we really go from very, very basic code level to eventually actually making your contributions. And we talk about, in the lectures, we talk a lot about the theory behind this, give some examples. But then next up, we do a lot of active learning. So in the classroom, we break up in little teams, and we use JPacman, which is a fantastic sample system from TU Delft to immediately practice what we did. And so here you see a couple of examples of just the second week where we say, all right, in Pac-Man, there's Pac-Man eating little pellets. Tell us how scoring works. And we haven't, remember, we haven't given them UML yet. We haven't given them any formal notations. They have to do this on their own. And so this is 2 examples of what they did. We notice that they're different, which is important, because what happens is in the team, they first have to talk amongst each other. So collaborative learning there. Then we brief out to the group where we go through some of the examples so that groups see how other groups did this. And actually, as a third component, we bring in a guest speaker from industry whose job it is to tie into the lecture. And actually, in this particular lecture, that industry person would read these diagrams that the students produce and give them feedback. Here's what I see. Here's what I didn't see. Here's what I would have expected. Here's how we would have done it differently. And here's where I'm confused. And that is actually incredibly powerful, because that means that first within the team, then across the teams, and then with the experts, they start learning how to actually talk about what they found and how to display that and share that with others. And then as the practical component, they have to work on an open source project greater than 100,000 lines of code. There's a lot of careful vetting that we talk about in the paper. And the first weeks, it's all about reading that code. So the first week is just build it, because that typically runs into some issues. The second week is find one feature, doesn't matter what feature. The third week is find a couple of essential features, things that are really, really important in this software. The fourth week is find some patterns. And then eventually we get to, okay, now that you've done this, find an easy pull request, or find an easy issue and submit a pull request. And here's an example of what we saw, which is most often the open source community was actually very welcoming, especially if our students said, this is our first pull request ever, blah, 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 blah. And they gave us this kind of feedback, like the comments say that the area index out of bounds exception is thrown, but that's no longer true. Unit numbers start from 0. Have you tested your code? And so what the students are seeing is a lot of what we talk about in class with the professionals and around the social context. They're starting to see that in action. And they're starting to learn some of the realities of submitting. Did you actually include test cases? Even though we talked about it, they still forget it the first time around, but they don't forget it the second time around. And there's lots, again, we do outbriefs on these experiences so that they see the kinds of things that other teams run into. So what did the students say afterwards? So these are some quotes from a survey we took after they had entered the internship, so about halfway through the internship in summer. And we asked, was this course useful to the internship? And so the first 4 comments are sort of the positives. So I also took a look at the unit test to better understand the purpose of the functions, the etiquette around pull requests. I made diagrams. I'm no longer afraid to contribute to the code before understanding the whole code base, which again, for those people who are career switchers is super important, because they were intimidated by something of this size. So overall, lots of positives, but also they want some more detail on design patterns and some other topics that they would like to see in more depth. Understood. And maybe the exam should be optional or only for students who need extra credit. And actually, in the incarnation that we're running right now, I just got rid of the midterm. It's just all based on the project. And that's it. So thank you. I'll end with a quote, which is, if you want to be a writer, you must do 2 things above all others: read a lot and write a lot. But we should teach you how to read. And that's what this course is about. And all the materials for anybody who's interested are freely available. That's it. Thank you.
Thanks, Andrej. Would you be able to share the link to the materials in the chat, and we can all maybe have a look? That'd be great.
Unfortunately, it's all hiding in Canvas, so I would have to give a manual download of that package. The university locks it down, but anybody who sends me email, I'll happily share.
Okay. Well, thanks. So this is an invitation for all of you to send Andrej a lot of emails. Awesome. Thanks for the
Totally.
Welcome. So that brings us to the unfortunately last presentation of this session already, which will be by Marcelo. Are you there? I see you, I think. and it'll be on DevOps education and his interview study of challenges and recommendations. So Marcelo, if you're able to share your screen.
Yes. Hi, everybody. Just a minute to share my
Perfect, we see
screen. Hi. Okay. May I start?
Yes, please, go ahead. We see your screen.
Okay. Hello, everyone. My name is Marcelo Fernandes. I will be with you throughout this presentation. I'm going to present you our research about an interview study of challenges and recommendations in DevOps education. The software industry has embraced DevOps practice because it can effectively improve product and service delivery capabilities. So, knowledge about these DevOps practices is essential for software developers nowadays. Unfortunately, DevOps is not usually part of the curriculum in many educational institutions, making it difficult to have a course as a reference. It would be helpful to know the main problems and the best educational practice to teach DevOps. Our work has two research questions related to challenges and recommendations in DevOps educations. In our work, the pool of interviewees came from existing DevOps courses. We found courses searching on GitHub, Google, Alura, and our contacts. We considered the search strings, DevOps course, continuous delivery course, and infrastructure as code course in GitHub and Google. We fortunately met great people, and we have learned a lot from them. We interviewed 14 educators from 11 universities in 5 countries. We have collected 83 challenges and 185 recommendations. For example, students have a prior concept that DevOps is restricted to the use of tools, not being interested in the cultural part of DevOps. Is a relevant challenge. That makes sense because it's hard to change student expectations to only learning tools. About the recommendation, they say, grade students based on their learning journey and mistakes, not on what they submit. What's important is how they get there, because every failure is learning opportunity. This excellent assessment technique is perfectly aligned with the DevOps culture. We grouped the challenges and recommendations into themes using the thematic analysis research method. The following themes were found: DevOps concepts, curriculum, assessment, tool and technology, environment setup, strategy in course execution, and class preparation. If you want to see challenges in environment setup theme, you can filter specific ones. We linked the DevOps recommendations to challenges when the recommendations can mitigate or solve the challenges. For example, you can mitigate the challenge, difficult in teaching students how to add new features without breaking the system, with the recommendation, incremental teaching method based on project and practical activities. Another link example, you can mitigate the challenge, difficult in structuring the learning journey, with the recommendation, merge good practices of problem-based learning, inverted class, and agile through classroom experimentation. You can find this diagram in the paper that shows the most cited challenges with links for their recommendations. You can also find all the data set we have collected. The download link is inside the paper. We also identified scenarios that represent conflicts between challenges and recommendations. One recommendation says, force students to use technology stack using on cars. Another one suggests, do not force the technology stack used by students in their systems. In this situation, we cannot decide if a strict technology stack is appropriate or not to use. If you are an educator, you can use the themes to navigate the set of DevOps challenges and recommendations. You can mitigate a common set of problems found when teaching DevOps using challenges, recommendations, and their links. You can use the most cited challenges and recommendations as a good start to consider when preparing a course. And you should prepare your educational methodology to motivate students to understand the DevOps mindset and not only learn technological aspects. And if you are a researcher, you can use the themes to navigate the set of DevOps challenges and recommendations. You can investigate challenges with few links to recommendations, and conflicts also represent research opportunity. You should investigate on the aspects of DevOps educations that our interviewees disagreed with. Thank you.
Awesome. Thank you very much for the short, sweet talk. Thank you to all the presenters in this session. This was great. So the idea was that we bundle sessions at the beginning to then have more time for discussion. And so that time would be now. So could I ask all the presenters to switch on their cameras and their microphones if they're willing and able to, so that we can see you up on the screen. And Marcelo, if you could stop the screen share, then we have the entire, I see everyone in large. Great. Jeff, can you still join us? There he is. Perfect. Awesome. So maybe we can just start this off with some of the questions that we had here in the chat, and please feel free to add additional ones. So Lavinia started us off with what I thought was a really fascinating question, which I would love you, Jeff, to answer, which you already did a little bit in the chat, but maybe you can elaborate. So what projects did you caught your attention in particular? Like, what did students come up with? This is a fascinating idea.
So thanks, and sorry for the delay. I was switching back and forth between lunch, so I had to swallow before I could talk. So yeah, there's some. The way I graded I mentioned the web development course. So I graded projects there was, I kind of set a bar where if they satisfied all the requirements, they got things to work, and they didn't, and the usability was sufficient based on what we talked about, right? Then it was, then that was a good project, and that got really good grades. And honestly, most of the students did really well. There are a few students who came up with something different. Like they came up with, these are pretty small projects. So for example, one semester it was sorting strings, and the functional requirement divergences were based mostly on the Unix sort options for the sort command in Unix. So it wasn't about the programming, it was about that environment, right? But a few students came up with just interesting ideas from a user interface perspective that I wouldn't have thought about that looked really good. So those stood out, and there are several of those. Some people came up with interesting, sort of more software-oriented ideas. So like using libraries to do things like input validation. I didn't realize how much JavaScript could do, and somebody came up with a map, because one of the issues with the web app is if you check the inputs on the client, then that doesn't ensure that the values are okay on the server. That's a bypass testing thing that I've published about. But there were a couple of people who mirrored their input checking on both sides, and that stood out. And others just really clean code. The kind of code people write will vary so much, so those stood out. And I saved several student examples, and I've used those as examples in future courses, as positive examples for here's how you can do certain things. following Andre's sort of you should read good code to learn how to write good code. So yeah, some did stand out. Should I go on to another
Great.
question? Somebody else
Yeah,
jump in?
maybe we can
Yeah,
just
Mark.
continue with you because I just see like another question from Valeria that's also to you. Yeah. So the question was, have you tried
I
to
didn't
apply
have
this idea
another
to other
question.
courses? Sorry, yeah, go for it, Lavinia. Go.
Oh, sorry. It's because my
No, go,
internet
go.
is not so great. But I was thinking just about, you mentioned like the technologies could be different, but how went the mentoring for that students so they could choose different technologies, how the mentors handle if they have some problems?
Well, by the time we got to the final exam, I told them that they should be self-sufficient with those kinds of problems. And we, throughout the semester, I emphasized two primary implementation technologies: the J2EE Java servlets, and the default deployment was on GitHub Heroku. It's actually hard to set up a Tomcat server, for example. It takes some specialized skills, and I gave up on getting the university to do that a couple of years ago. So, but GitHub Heroku worked really well, and we also talked about React.js in the course. If you're not, I don't know how familiar you are with web development, but there are lots of JavaScript-based frameworks for building web applications, dozens probably. And we talked about one in the class, but other students knew something else. But in the final exam part, I said, you should be able to solve these problems yourself. And the few who didn't, they reach out to me and I helped them a bit. But one did reach out to me with another JavaScript framework, and I said, I don't know. Feel free to start again with something that I know. But he did actually, he did figure that out eventually. And most students did go with the Java-based technologies. That was more than half in every semester.
Okay, so you presented some versions that they were able to use and that you would maybe be able to provide more insights in than with other frameworks. Is that correct?
Yes.
Okay, cool.
Can I
So
ask
maybe
a
we'll-
question?
Yes, of course, go for it.
So first, I want to thank Jeff for presenting this interesting paper. So could you tell us a bit more about what challenges you when you're creating this coursework and what didn't go as you expected?
So the coursework or the final exam?
Yeah, the exam, yeah.
Yeah, okay. Well, the first time I did it, I got the size wrong. So the size of the program they're supposed to build, and I actually had the model in my head 2.5 hours for final, and they all came to Zoom. I gave them the assignment. I shared that with them we talked about it a bit, but I also shared it through the web. And I had several people work through the final exam, and it took between 30 minutes to an hour and a half. So I thought this is good. Graduate students. What I hadn't allowed for is the fact that some students need a lot, or some programmers, not just students. Some programmers need a lot more time than others. And I don't think it's really reflective of how good they are. Sometimes we just make a bad decision and it excuse me, sends us down a rabbit hole for quite a bit of time. So I just sort of on an ad hoc basis said, okay, I'm not going to worry about the time limit here. And I had people working for 6 or 7 hours. And so the next time I scaled back the assignment because doing more didn't actually help me with that, with that kind of assessment or helping them demonstrate their skills. But I also said, you have a 24-hour window. This should take an hour, 2 hours max, but anytime you submit in the next 24 hours, and that's okay with me. And, some students, that gives them more time if they need it, but it also means they can go to sleep or they can take their next final and then come back to my final. And it reduced a whole lot of stress and I think the results were just as good like that. Okay. So that was the biggest change there. Somebody asked about other class. I've also done this personally in a senior level software testing course. Yep. And it's similar, but it's very different because what I did is I gave them software. just a small program, and I said test it. And there are details in the paper if you really want to know. But the time it took students didn't vary as much. It's mostly a design process to design tests. So it didn't have that issue. The key there is to find software where they're domain experts. They understand quickly what the program should do. And that's not too big and not too small, but has some methods, because testing isn't interesting with getters and setters, right? It's more interesting if there's some complicated control flow going on. So I had to find software that had that. So that's the biggest challenge from creating that kind of exam.
Okay, thank you. What would you think the applicability of your proposal if the number of students grows?
I guess there's a limit as far as the level of divergence, but the fact that I've done this with up to 70 students, and nobody's solution was even close. I'm pretty sure that for the two classes I've done this with, it would scale up to 100 or 200 students. Thankfully, I've never had to teach courses that big, but maybe in the future our enrollment is growing. But I think I do think it would scale up pretty far, but it's going to depend on the course as well. I think this is not going to work as well in, say, an introductory programming course, because they're so small. There's less. It's harder to put the divergence, and the students don't know as much.
All right. Thank you very much for your answer.
Okay, so maybe we can switch over to Andrzej. We have an initial question here from Clinton, which was, did you get pushback from students on spending the semester the way that you envisioned it? And were you able to convince the doubters?
There's always some doubters you will never convince. So I think that we're just going to put up front right away. But I do think in the beginning they do have to think about or they have to think about a relatively small program, right? And so for the folks who have been doing this for a while, it's fairly easy for them to go, it's over here, it's over there. But once they then start learning sort of the more advanced concepts, and that there are some smart ways about going about code reading, and that there's ways in which professionals part of what we do is we embellish the course also with lots of additional resources, right? So I will point to YouTube videos of professionals who are doing an exercise in code reading, and they'll have their laptop and a whiteboard, and you see them taking notes on the whiteboard because they have a non-trivial task at hand, and they need to keep a lot of things in mind. And once they start seeing that it's not all about being just a really good, person with the keyboard who can quickly find things, but that there's actually smarts needed, and that you can not brute force it all the time, they start coming around that, okay, maybe some of these strategies and tools and approaches are actually helpful. And the second bit that really helps is I make it fairly explicit that, look, when you graduate, you want to have some sort of things that you can point to, right? And one of those things you can point to is if you've made pull requests to an actual repository and they've been accepted. And that is a good motivator for them, right? And the ones that are really good, I'll challenge them and say, look, yeah, you could do a 2-liner, but you could also make a more serious pull request and see how that goes. And in that case, they then start realizing that they're learning for themselves, right? And they can step up their game that way. But there's always a few that are like, yeah, no, I know this stuff, don't worry. And that's okay.
So maybe related to this, Dom asked about sort of the tool usage. So mature tools for reading and understanding code. Do you introduce those to students? Do you want them to use those? What do you rely on for students to read code?
By and large, we rely a lot on IntelliJ and its plugins. For instance, but they're still fairly simple. They're not the research tools yet. So I sort of feel like I should give them the kinds of tools that they can use in future. So we do talk about sequence diagrams, generating class diagrams, the visualizations, call graphs. So sort of the more traditional things that help them get a sense of what's there. But then I do point them to some researchy kind of tools like CodeCrumbs and others for them that will help them, as things that they can explore on their own. And let me answer Lavinia's question about
Lavinia,
why is
another
this in a
question.
professional math program? Yeah, I think that's actually a really good one. It's in a professional master's program for two reasons. One is that there's an audience there that is switching careers, and for them to learn how to deal with something large is important. The second reason is purely pragmatic. We got to design it from the ground up, right? So we got to design it from the ground up with all the courses that we wanted to put in. So there was a space to do this. Now that I've created the course, I actually would like to bring it to the undergrads because it's equally valuable for them. But as with Jeff, the scale will be larger. Right now, we're running it with 40 to 50 students. I would have to think about how to run this with 200 students because I know that if I offer this course, we got 2,000 undergrads in CS, we got 500 game design students, we got 500 informatics students, 700 software engineering students. As soon as I put on this course, there's going to be a lot of demand. So I have to think about how to scale that.
Very cool. Thanks for the answers. So maybe we can switch over to Marcelo. I think there was some interesting discussion in the chat here. Maybe you can comment on this already, and I think you answered some of the questions. So maybe can you elaborate a little bit on? So there are lots of challenges in DevOps, right? Just like communicating with different teams and having tools, and then there is the challenge of teaching DevOps, right? Are those two areas separate, or do they overlap to a certain degree? Would you say?
We didn't distinguish if one challenge is around the education or around the DevOps specifically. So we already have some challenges that more related to the education part, and other challenge is around the technical, the DevOps. For example, stay up to date with DevOps tools. It is a DevOps challenge. It's about the technical part of DevOps, because we have many tools and to work with DevOps, and it's really difficult to know which tools should I use and how do I keep up to date with so many releases, with so many changes in these tools. So this is an example of the challenge that is more related to the technology, the DevOps part. But we also have challenges related to the education. Right? We have these two phases. So we have a challenge, for example, to change the student's mind. Hey, DevOps is not only tools. We have the mindsets to learn too. We have to integrate the dev and the ops people. They don't have to work in silos. I'm sorry, the right answer, but in separate people, in different teams. Okay, so we have to learn more about the culture. We have to use agile techniques. We have to use lean techniques. These are more related to the DevOps culture. The DevOps, they're not only tools. Okay.
Yeah, very good answer. So you also mentioned that one of the recommendations was setting up tutorials and sort of scaffolding the learning. Are you aware of any like amazing projects here that you would recommend we check out?
Yeah, this is what all of these recommendations are collected from the interviewers. Okay, and this recommendation about using tutorial, this is cited a lot of time. So the professors, né, they use these recommendations to help in their labs. When they do the labs, when the students want to set up the environment to run the labs, they say, hey, use the tutorials, because the people can follow the instructions and do the what has to be done. Okay.
All right, thanks for the answer. Andre, did you want to follow up on the discussion in chat here with some words about evaluating reading code?
Yeah, I was just furiously typing. So it's nuanced. In the sense that in some ways I don't care to really assess them, but that's not quite fair to say. So I did have a midterm and a final because that's what you put in a class. Hey, Dana. But it's like, it assesses on a really small program. And this is all about large-scale software. And I can't really put them in front of a piece of large-scale software and say, within this final or midterm, do this. So what in the end we came to is in talking to some of my colleagues who are in our informatics department who have an education background, that they actually have educational degrees. The strategy that they use a lot is, work on a project, submit your stuff by the deadline. We'll tell you what you did right and what you did wrong. And if you did it wrong, go fix it and we'll grade it again. And if you still did things wrong, go fix it and we'll grade it again. I haven't gone quite fully in that direction that you can do this infinite numbers of times, but certainly they're allowed to resubmit things that didn't go well. As a result of which, I feel like they're allowed to experiment, they're allowed to try, and hopefully by the interaction with the TAs and me, they will start understanding what's there. Can I prove to the employers that will hire them in the end that these are the folks that they want to hire because they got A's in my class? Absolutely not. But I do think that ultimately learning is a student's responsibility. And we talk a lot about how you can talk about a course like this, especially with the guest speakers, the professionals, during your interviews. Right. And the ones that want to learn and the ones that want to adopt this kind of material, they will listen very carefully and they'll practice and they'll be able to use the stories from the course to hopefully impress the interviewers. And I think that's kind of what I tell them. Right. It's like, I am actually not the gatekeeper. I'm going to give you a bunch of material. It's your interviewers that are the gatekeepers. And that's where the true assessment will happen. And that's up to you what you want to do there.
I love it. I also teach a lot of experiential learning. I use the experiential learning approaches. And I think it's in the questions that they ask and the mistakes that they make and the reflections that you embed in the experiential learning. Those stages are opportunities for them to learn, right? Yeah. And those who just sit back perhaps and do nothing, you can say, well, they haven't learned much and maybe you penalize them on the grade. But otherwise, it is how they get involved with the code and the questions that they ask and how they pick it up when they make mistakes. Thank you.
You're welcome. Thank you.
So Jeff, I've seen a few people in the chat that say like, oh, I will definitely try this out. Can you maybe share your top recommendations for people who are willing or who want to try out your approach? What would you mentor them about?
That's an interesting question. I hadn't really thought about that. I think I'd suggest start thinking about it early. So you need, for whatever course you need some sort of problem or assignment that will fit, right? And I think that's a very creative process, more creative than most exams I've made out of my life. Pulling questions out of slides and then expecting them to answer the question. So I think starting early helps. I come to think of it, more important than that is to do it yourself. Because one semester I had, they were doing things with logical predicates. And I thought, well, that'll be easy. These are all computer science, software engineering students. They're good with logic. They took discrete math. But then one of the things I had them do was take a logical predicate and print the truth table. And so I decided I'd try it, and it turns out printing a truth table from a from a logical predicate is actually quite complicated because and the algorithm is confusing. And I spent 2 or 3 hours designing this algorithm, and I was really close. And I thought, wait a minute, oh no, that's not going to work because of this. And I thought, wait, what am I doing to the students? And I looked online, and I found out there are all sorts of algorithms and recursive algorithms that were pretty simple and straightforward once you saw them. So I added that to the exam. I said, here's an algorithm. I suggest you use this. Don't try to come up with your own, because it was not an algorithms class. That was not what I wanted to test them on. So try it yourself, and you might just find something that would have created major problems. Mixed use. So the other thing I've done is in the testing class, I think every Divergent exam I've given like this started as a project in the web development class. So that crossover helps. And that also, the great thing about using a web project is I can give them a runnable version. They don't have to compile. I just give them the URL. And so that helped with that. So the crossover between classes can really help with that. So yeah, start early, use other class projects, and make sure you try it yourself.
So I would imagine maybe if you're willing and able to try this out, one of the questions that will come up is, did you use a grading rubric, or what if multiple people need to grade these things? How do you coordinate?
I've almost always taken full responsibility for finals by myself. Only a couple times have I gotten help from truly excellent students. I think Upsorn is here, in fact, back when she was a student here. But yeah, that doesn't mean the question is relevant. But I think the rubric for me was actually fairly simple. For the testing class, for example, I gave them test criteria. So did they design tests that satisfy the test criteria? And did they apply that correctly? The model they created, like a control flow graph, for example, is a common model in testing. Was it a correct representation of the program or the method they were testing? So in that sense, fairly straightforward. And I did assign points based on each different piece. And for the choices they had, I'd make sure that added up 4 points a piece or whatever to add up to the right number. But generally the rubrics were pretty simple, so I think it would be possible to turn that over. The hardest part with the courses I've done so far is evaluating usability with the web development course, because it takes a lot of judgment, right, with respect to grade usability. And for that one, I really just said it as, did they do anything really bad? Right, as opposed to brilliant user interface, did they do anything really dumb that we said in class, don't do this, right? And we had a lot of principles in the course, so that was, that sounds too simple. It was not exactly that simple, but it was pretty straightforward, and there wasn't a lot of qualitative. How good is this? And
okay, but interesting approach using like sort of an anti-pattern, right, to check. Yeah. Sorry, Adriana, please go ahead.
Oh yeah, I just wanted to follow up on the grading rubrics. Were the students happy with it? Like, for instance, for the software development course, with the rubric that you provided? Because in my experience, I have TA for many courses, and they always want like a rubric up front, to try to get a good grade in the end. So
so I do a couple of things. One is I did give, and maybe this is back to Christoph's earlier question, I gave them a practice version, which is much simpler, but so that they went through the process. And like one thing I found out with the web development course is they worked in teams of 2 or 3 or 4 all throughout the semester. and some of them had never actually deployed their programs on GitHub with Heroku, yet they had to do that themselves for the final exam. And they found out through that rubric that, oh, I have to, or I'm sorry, through the practice exam, oh, I have to learn how to do that. And I said, and after the first time I saw that, I've told the students multiple times, make sure you know how to do this, even if your partner is usually doing the deployment. It's IT work, not really the software engineering part, but it's IT work they have to do for this course. What I found is that some of our students are really initially uncomfortable with the idea that there are choices, right? That they can do this, or that, and the rubric can't be too specific, because the whole point is to get that divergence, and rubrics are sort of anti-divergent in some sense.
Yeah.
So initially they're really, I think they're stressed about it, but once I get across to them, it's going to be okay that you do something different. Your solution doesn't have to look like mine. They became okay with it. And I think some of them, it's not till near the end when they realize, oh, this was not so bad. But that's where that practice really helps. That they understand that it's okay if things look different. That's what I want, in fact. Maybe I haven't thought enough about the rubrics. Now you're making me think back here. Maybe I should make that clearer, but I don't know how to do that without reducing the divergence, frankly.
So Jeff, just to give you one quote for why you should not do the rubrics more precise. I was on a call yesterday with an engineering manager, and they said, I have real trouble hiring people. And I've come to the realization that I don't want to hire the A folks who exactly know how to program to the rubric. I want the B and C folks who struggle, because they have actually had to do some serious problem solving and introspection on themselves. And I think that there's a sad truth in that for some students.
Exactly right. My wife is a hiring manager, program manager at a company, and she tells me, no, don't tell me about your 3.9 GPA students. I want your 3.2 GPA students, the ones who did struggle a little bit. And then she says, mainly I want the people who know how to work with everybody else. And that's, a broad CS kind of problem.
Yeah.
We don't teach collaboration enough.
Nope.
Okay, so we would have another 2 minutes for one last short question, if there is one in the audience. Feel free to speak up. Otherwise, thank you very much for all of the great talks. Thank you very much for joining in this lively discussion. Thank you all for being here, and I look forward to seeing you in the other sessions of ICSE. We do have another 2 minutes in this session, so feel free to ask another questions if you want. Otherwise, thanks very much for being here, and I hope to see you around.
I had a lot of fun, and Christoph, thank you for hosting this. Great job.
No, absolutely. This
you.
is I'm talking about software engineering education is like something that I love to do. So it's great to hear your experiences. Did you actually, Marcelo, did you run into problems with all the or many things being behind like Canvas walls when trying to figure out what people were teaching?
No, we didn't work with Canvas.
Right, but you collected like a bunch of DevOps courses, right? And I was wondering, like,
yes.
Nowadays many of the courses are maybe like behind this like Canvas wall where like it's
many of. Okay, I think I understand your question. Many courses are available. Okay, some of them we have only a single paper, a single page with the curriculum of the course, but other course we have the complete course available on GitHub, so I can share all the information about this a complete course from DevOps, so I can share with anyone that can.
That's
can
really
use.
cool. I think that's
Okay.
like a really cool contribution from your paper. Actually, it's just this like giant collection of like DevOps courses. I mean, that seems like a really cool resource to go to.
Okay, thank you. Appreciate.
Awesome.